Solve 2x plus 3 equals 4x minus 5. Again, our goal is to get the variable alone on one side of the equation, but here we have something new. The variable is appearing on both sides of the equation. When we have a variable that appears on both sides of the equation, we need to eliminate the variable term from one side so that we can have the variable only on the other side. In this case, we can do this by subtracting 2x on both sides of the equation. If we subtract 2x on the left-hand side, 2x minus 2x is 0. These terms actually cancel, so we're just left with 3 on the left. On the right-hand side, 4x minus 2x is 2x, and so we end up with 2x minus 5 on the right-hand side. Hopefully you see how this eliminated the x on the left. We had a 2x term that we wanted to get rid of, so we simply subtracted 2x to get rid of it. Now there's only one x in the problem on the right-hand side, and so our goal is going to be to isolate it on the right-hand side. To do this, we add 5 to both sides to get rid of that negative 5 term. That gives us 8 on the left. 3 plus 5 is 8, and leaves us with 2x on the right. And the last step to getting x alone is dividing by 2. When we do that, 8 divided by 2 is 4. And on the right we have x, so 4 equals x. Or if you want to put the x on the left-hand side, you can switch the sides and write it x equals 4. Sometimes people really like to have the x on the left-hand side because it makes more sense in the English language. If someone asks you, find the value of x, it makes more sense to start your sentence with x and say, oh, x is 4, instead of saying 4 equals x. Because here we're saying something about 4 and not x. It doesn't really matter. Either one is acceptable. You can choose whatever you prefer. Now I do want to show one other way that we could have solved this problem. 2x plus 3 equals 4x minus 5. The way we did it the first time was we got rid of the 2x by subtracting 2x on both sides. But we could also instead choose to get rid of the 4x on the right by subtracting 4x from both sides. Let's do that and see what we end up with. On the left-hand side, 2x minus 4x is negative 2x, and we still have that positive 3. On the right, 4x minus 4x is 0. They cancel out, and we're just left with the negative 5. Now we can still solve for x, but the thing that's more difficult is we have a negative coefficient on the x, so in the end we're going to have to divide by a negative number. It's not impossible, it's not even that much more difficult, but when we have more negative values in the problem, there are more opportunities for students to make mistakes. So let's finish this, and then I'll give you a strategy for deciding which term to cancel. So we want to get the negative 2x by itself. We can do that by subtracting 3 on both sides. That leaves the negative 2x alone on the left. Negative 5 minus 3 is negative 8 on the right. And then to get x alone, we have to divide by negative 2, because x was being multiplied by negative 2, and the opposite of that is dividing. Now, negative 2x divided by negative 2 is just x. On the right-hand side, a negative divided by a negative is a positive, and 8 divided by 2 is 4. So we do get the correct answer, x equals 4, but there were so many more negatives in this problem that there are a lot more places where we could potentially make a mistake. So I really prefer this first method. And the difference here was which term we decided to eliminate. Here we decided to eliminate the 2x, and on the other attempt we decided to eliminate the 4x. When you're picking a variable to eliminate, you'll always have two choices, and one of those choices is going to leave you with a positive coefficient on the x, whereas the other one's going to leave you with a negative coefficient. And if you pick the choice that leaves you with a positive coefficient on the x, your life is going to be just a little bit easier.